Okay, so we're going to start this lesson by doing more multiplication. Now we're going to multiply more than just monomials. Let's talk about what happens when you multiply polynomials or a monomial by a polynomial. And we're all very familiar with this. So our first example will be 3x to the fifth times the quantity of negative 2x to the fourth plus 6x to the third plus 5x. So when you have an expression and then parentheses, we have to distribute this in. And how do I know that I have to distribute it in instead of just multiplying the like variables together? How did I know that in this scenario I actually have to distribute in, where yesterday we were just multiplying the like variables? Excellent. The minute we have in that polynomial the addition or subtraction sign, whatever term is in front of it has to get distributed in. So we're going to have 3x to the fifth times negative 2x to the fourth, and that's going to give us negative 6x to the ninth. And then 3x to the fifth times a positive 6x to the third is a positive 18x to the eighth. And 3x to the fifth times a positive 5x is a positive 15x to the sixth. And then we look, any like terms here? No, so this is as simplified as we can go.
Can you pull out the GCF of 3?
Well, you could pull out a GCF of 3x to the fifth, but then that brings us back to where we started. So we're not factoring, we're multiplying, so that's why we're distributing that in. Okay, same idea. I have a trinomial multiplied by a monomial. I need to distribute that y to the 3n in. So when we have y to the 3n times y to the 1n, what do we get there? Y to the 4n, very good. And then I have y to the 3n times 2y to the 2n, gives us 2y to the 5n, excellent. And then y to the 3n times 4 is 4y to the 3n. Once again, no like terms, so we leave it just like that.
Does it matter, like, if 5n has to go first in the...
No, you're right. Usually I put it in descending order or final answer, but addition's commutative, so ultimately it doesn't matter.
Wait, can we only add if the coefficient is the same?
If the exponents are exactly the same. So we have a 4n, a 5n, and a 3n. Because it's not the same number in that exponent, just the same variable, we can't add them. So now I'm going to have negative 10 a to the n, b to the n times the quantity of a to the n, b to the n minus 7ab plus 8. So again, we have to distribute. So I'm going to get negative 10 a to the n, b to the n times a to the n, b to the n gives us negative 10 a to the what? 2n, b to the 2n. Now, do you guys all agree for this negative 7ab, the a has an exponent of 1 and the b has an exponent of 1? So then when I multiply this, I have negative 10 times negative 7 is a positive 70, right? Negative 10 times a negative 7 is a positive 70. A to the n times a to the first is a to the n plus 1, right? We add our exponents. And then what's the b going to be? b to the n plus 1. You got it. And then lastly, we'll have negative 80, a to the n, b to the n. And again, no like terms, so we leave it just like this. So when we're multiplying two binomials, what do we call this? The process of multiplying the two binomials, Ariana? Foiling. We got to FOIL. I call it double distribute, but I know everybody else calls it FOIL. So here we're going to have 5x times 5x is a 5x squared. 5x times a negative 14 is a negative 70x. Then we have 2 times x is a 2x, and 2 times negative 14 is a negative 28. The middle terms are like terms, so we end up with 5x squared minus 68x minus 28. Is this 81 minus 4x to the fourth? How many people say yes? How many people say no? Good, you all win. You didn't fall for it. Why no? Why can't I distribute in that exponent? Amanda?
Because it's a binomial.
Excellent, it's a binomial. So we cannot distribute in that exponent. We have to multiply it out. So this is 9 minus 2x squared times 9 minus 2x squared. 9 times 9 is 81. 9 times a negative 2x squared is a negative 18x squared. Negative 2x squared times 9 is a negative 18x squared. And negative 2 times a negative 2x squared times a negative 2x squared is a positive 4x to the fourth. So if we combine our like terms, we're going to have 4x to the fourth minus 36x squared plus 81. Very different than 81 minus 4x x to the fourth. Very different. So now I have a binomial times a trinomial, and all I'm going to do is triple distribute this in. So a times a is a squared. A times b is an ab. A times 1 is a. B times a is ab. I usually put the variables in alphabetical order, but you don't have to. B times b is ab squared, and b times 1 is a positive b. And now we combine our like terms. So I'm going to have a squared plus 1ab plus 1ab is 2ab plus, do we only have one a here? Plus a plus b squared. Does that sound right? Does that look right? Yeah? Okay. And again, addition's commutative, so as long as you got this, it could have been in any order you wanted. Okay, last one of these. I'm going to have you do this on your own. But before I have you do it on your own, what do we have to do first here? There's no choice about it. What's your name? Anishka.
You have to FOIL the x minus 2y.
Good. You have to perform the exponents first. We have multiplication and we have exponents. Exponents has to come first. So you have to FOIL the x minus 2y before you multiply in the 5x. All right, who has a product for me? Charlie, yeah.
5x cubed minus 20x squared y plus 20xy squared.
Perfect. Does anybody need to see me do this? Y'all got it? Okay, so that's the end of that recap. We're finally going to get into something you haven't seen before. So this is called synthetic substitution. I think I wrote in the heading synthetic division, but it's synthetic substitution. They're interchangeable. Okay, so this first problem is asking us to evaluate 3x to the third plus 10x squared minus 5x minus 4 when x is equal to 2. So the way we're most familiar with is called direct substitution. And with direct substitution, what we do is we say, okay, x equals 2. So I'm going to go back to my expression, and wherever I see an x, what am I going to substitute in? A 2. So let's do this using direct substitution. We have 3 times 2 to the third power plus 10 times 2 to the second power minus 5 times 2 minus 4. And we do have to follow order of operations. We have to follow PEMDAS here. So I want to perform my exponents first. So we're going to have 3 times 8 plus 10 times 4 minus 5 times 2 minus 4. And now that we simplified our exponents, now we're going to go into our multiplication. So 3 times 8 is 24. 10 times 4 is 40. Negative 5 times 2 is a negative 10. We have minus 4. So here I can add and subtract in any order. So I'm going to say 40 minus 10 is a positive 30. And then I will do 24 minus 4, which is 20, plus 30 is 50. So I just added in a way that was easiest for my brain. But you could do whatever you prefer. Okay, so this is called direct substitution. This is what you've been doing probably since middle school. So now I'm going to show you something called synthetic substitution. Take the same exact problem, so our first step is we want to make sure polynomial is in descending order and every exponent is accounted for. Okay, so what does this mean? Descending order means your biggest exponent all the way down to your constant. So my biggest exponent is 3 all the way down to my constant, which is negative 4. And then it says make sure every exponent is accounted for, meaning if my biggest exponent is 3, I need an exponent of 2, I need an exponent of 1, and I need my constant. Do I have all of that? Yes. I'm going to put every exponent and constant. I'll put and constant is accounted for. So in this scenario, everything's accounted for. My biggest exponent, we're all the way down to my constant. Every exponent in between is accounted for. Then what you want to do is once you make sure of that, you're going to write the coefficients / constant. So we're going to say no variables. So I'm going to do that over here. So my coefficients are 3, 10, negative 5, 3, 10, negative 5, negative 4. Okay, then what we want to do, put the value of the variable on the outside boxed off. And the value for x is 2. We're then going to bring down the first number so I'm bringing down the 3. Then multiply it with the number in the box. All right, so I brought down the 3. I'm going to multiply it with the number in the box. 3 times 2 is 6. Then put that product in next column and add. And then we're going to repeat the process. So repeat the process in number 4. Okay, so we brought down the 3. 3 times 2 is 6. We put it in the next column, and now we add. 10 plus 6 is 16. 16 times 2, 32. Negative 5 plus 32 is a positive 27. Positive 27 times 2 is a positive 54. Negative 4 plus a positive 54 is a positive 50. Answer is the sum of the last column. So what sum did we get in that last column? 50. Is that what we got with direct substitution? Yeah. Okay, let's do another one. Yes.
How do we do the graph?
How did we do what?
How do we do the graph?
The graph?
The chart?
Oh, the chart. So we put our original problem, 3x to the third plus 10x squared minus 5x minus 4. We laid out all the coefficients without the variables, and the number we wanted to substitute in, the 2, goes in the box on the outside. Okay, let's do another one where we're not stopping to write out our steps. So I want us to evaluate using synthetic substitution. Two x to the fourth minus x to the third plus 5x plus 3 when x equals negative 2. Okay, before we do anything, we first want to make sure it's in descending order. Is my expression in descending order? Yes. Then you want to make sure every exponent is accounted for. Is every exponent accounted for? No. What are we missing? Charlie?
The x squared.
Good. We're missing the x squared. We need to add in the x squared. So what we're going to do is we're going to rewrite this. 2x to the fourth minus x cubed plus 0 x squared, right? I'm not changing the value if I put a 0 there. Plus 5x plus 3. So my constant is even accounted for there. Now are we in good shape? Okay, so now what we do is we're going to write out all the coefficients, but don't bring the variables, just the coefficients. So we're 2, negative 1, 0, 5, 3. What number am I putting in the box? Negative 2. Perfect. You okay with how we set it up? Okay, so now what we want to do is you're going to bring down the first number. So I'm going to bring down that positive 2. And you take that first number and you multiply it with the number in the box. So 2 times a negative 2 is a negative 4. You're going to write that in the next column. And then add that column. Negative 1 plus a negative 4 is a negative 5. Now we're going to repeat this process again. Negative 5 times a negative 2 is a positive 10. 0 plus 10 is 10. 10 times a negative 2 is a negative 20. 5 plus a negative 20 is a negative 15. Negative 15 times a negative 2 is a positive 30. 30 plus 3 is 33. What is my answer? 33. All right, we're going to have you try one on your own, and then we'll be done for the day, and I'll give you back your tests. So last one, you're trying this one on your own. So you probably noticed that I didn't put your grades in Genesis yet, so I'm going to put them in now as I give it back to you. Actually gonna stop recording this.